Okay, in this video, we will use PXF run multiple vehicles to run a selection of vehicles on a selection of processes, but this time we'll also change parameters and initialization files. Oftentimes when you're running a study, you'll want to do that type of thing. You'll have the performance maps for an engine. So you'll have your fuel rate as a function of torque and speed, and that will be in a M file or initialization file, along with some of the other engine characteristics. So it's convenient to change the engine by changing an M file that defines the engine characteristics. You can do the same thing when you want to change the motor characteristics or the battery characteristics. Sometimes, though, you just want to change one parameter. Maybe you just want to leave the components, the engine, the motor, and the battery the same, but you want to adjust the engine size to get a certain performance criteria. So what we'll go over is how to change the initialization files and how to change the parameters using the PXF run multiple vehicles. So what I'll do is similar like we've had before, is we'll define a vehicle list. So in the vehicle list, we have the A vehicle files. So in this one, we have a conventional and a power split. And then I'll also copy in a list of processes. So in prior examples, we had the same type of thing where we had a list of vehicles and a list of processes. And then what we did is for every vehicle, we associated to a given process. What we'll do this time, though, is we'll also add in some initialization files. So that's what I'll do in this case. We'll call initialization list. And we'll add a couple of files here. You can find initialization files in the autonomy energy repo. So if you go into the vehicle folder, so autonomy energy systems vehicle, you'll have a list of the systems or components that a vehicle is composed of. And within these, within the vehicle propulsion architecture, there are different components. So the engine is ENG. So what we'll do is select different engine files. So if you wanted to see all the different engine files, you could go into the init folder here and see a whole collection of different types of engines. So what we'll do is we'll choose a couple of these engines, and specifically we'll use the A-init file. So the A-init file is what's defining the characteristics of the engine for the API. So the API can understand that M file and know where to insert it in the vehicle file before running. So what I'll do is I'll just copy in a couple of engine files. So it's a gasoline 2-liter port fuel injection, single overhead cam. And then we have another engine here, which is a spark ignition, 2.2-liter, 110 kilowatt spark ignition direct injection. It was collected at Argonne or ANL. Let me just close that. So that's just a couple of initialization files. And then we'll do a parameter list. So for our parameters, we'll just define an array. So this is the maximum power of the engine, and we'll just define a 2-row, 4-column array where the first column is the name of the parameter, and the remaining 3 other columns are the values for those parameters. This could be done in any way, whatever is convenient in this example, it's just convenient to do it this way. So in the workspace, these are values are in watts, and the vehicle mass is in kilograms. That's typical for the workspace unit. So the workspace unit is always in metric, where the unit that's being used in the user interface, that's display, is a separate unit. So we have vehicle list, process list. We have a list of initialization files that we're changing, and a list of parameters we're changing. So then what I could do here is we'll create that vehicle runs class, vxf run multiple vehicles dot create and run using defaults. So we'll create that. And then we'll do vehicle runs dot, oh, actually, one thing that we could do, I don't know how important it is to do it in this case. Let's do a loop then. I could, like we did last time, we had a list of row labels to create a nicely formatted table at the end. So we could do that in this case. And what we'll do is we'll do a loops then. So we'll loop over the vehicle list, or let's call this the index for the initialization file, which is copy paste that. What we can do, so if we want to do multiple combinations, so we have the vehicles, so we're doing each vehicle, and then for each vehicle we're doing this engine and this engine. We can also do something like iterating through the parameter values. Oops. So we'll iterate through each parameter value. And actually we could, let's see, do a single run here. So this is where we create the single run. And in this single run, we'll pass in the vehicle list. Okay, so just like last time, we're passing in the vehicle into this single run. But in this case, what we want to do is we want to change the file. So there's a method called change eval file. First one is the path, which in this case we don't have to use. It will find the file on its own. So we just want to take the first file and make that change. And then we're going to also go through and change the values. So what we want to do is we want to access the name first. So we're getting the name. And I don't think we need this other. Don't think we need that one. Let's see, because we're changing the initialization file. So for that, for this vehicle, so we're defining the single run for that vehicle, and it's good to define one for each individual run. So we're running this vehicle with each individual initialization file. So we're going to do the first run with the first initialization file. And then what we want to do is we want to go through and add the parameters to it for the first initialization file. So we get the first column. We don't need this specifically. Let me move this down here. Let me straighten this out. And then we want to get the parameter value. We do parameter values, we do parameter list. And we want to do the first parameter. So we're iterating each parameter, and then we want to get its value. So on this simulation, we're going to set its value index. So now for this vehicle on this initialization file, we set the vehicle, we change the initialization file, and then we're going to change the parameters. And we go through the first parameter, and then we go through all the values for it. So we get the name, we get the value, and we do single run dot change parameter, and we do the parameter name, and then we want to do a number to string. It will do the conversion internally, but the assumption is it's actually modifying the A vehicle file. So because it's modifying the A vehicle file and everything in the A vehicle file is a string, it will go and essentially modify that first. So we want to do that first. And then what we'll do is for this combination of initialization file and parameter value, we want to make sure that we run all the processes. So we'll have this vehicle, first vehicle in the list. Then we'll choose one of the initialization files, and we'll run both initialization files for that first vehicle. And then we'll go through and then run the parameters. So we want to choose the first set of parameters and then choose the second set of parameters and set that here. So we're changing two parameters inside. And then what we're doing is we are iterating through the processes. So we want to go through our process list. So I do a single run, and I could add these processes all in one go. So so what I'm saying is for this combination of vehicles, so I'm defining a vehicle. So that's what these first few loops are doing. It takes a vehicle, changes the initialization file, changes the parameters, and then for that vehicle that I'm running, I'm going to assign a couple of processes for it to run. So that's what I'm doing here. So I'll assign, that adds the process. We could, could use these vehicle row process label, initialization file labels. So I could add those in. So that when we build the table, we'll have each run defined. So we'll have the vehicle from the vehicle list. Oh, I put J there. That's the vehicle from the vehicle list. Then what we'll have is we'll have the process row. So let's do the process next. So let's add the process from the process list. So I'm adding that, and then I'll have the initialization. So each one of these is a separate row in it. So let me get this initialization. Ooh, that's not an initialization list. Then let me put the init IDEX there. Oh, those should be the initialization row labels. So that should be okay. And then I want to add that whole thing to my vehicle runs. Oh. Add run vehicle process. And that's a single run. So I get a vehicle from the vehicle list. Then I also get, for every vehicle, I'm changing the initialization file. So I'm changing the engine initialization file. And then for every time I change the engine initialization file, oh, I'm changing it on the run. So these would be, I could put it in here. So that's really my combinations that I'm having. So what I'm doing is I have two combinations here times two combinations here times three combinations here. So I'm choosing each vehicle then I'm choosing one of the initialization files, then I'm changing the parameters. I'm going through one of the columns. And because it's one of the columns, so this defines an entire run. So create a new single run based on the vehicle. Then I change the initialization file for that single run. And then I loop through the rows here, get the name of the parameter, get the value of the parameter, set the name and value for that parameter on the single run. And then I go through, and for that single run, I pile on a bunch of processes that I'm going to run. So I'm iterating through some combination of vehicles with a combination of initialization files, with a combination of parameters, and then with a combination of processes. So that will build out my labels for each one. Then I add those to the single run. I add the single run. And then what we can do is we can run it. One thing that we can do if I initialize this, we can run it faster. By setting this number of parallel runs. So it will open up multiple sessions of MATLAB and run the simulations in those additional sessions of MATLAB, so it'll run faster. Depending on the number of cores that your machine has, you might be able to maybe even get by with more on this machine. So in this case, it's running locally and it's just opening up additional processes. So for that case, you don't need the distributed computing toolbox, but we'll run it first like this and get our results. And then we'll come back and then I could show you how, if you had the parallel computing toolbox, you could run it using the parallel computing toolbox that MathWorks provides. But this is a pretty simple solution. If you're just running it on a single machine, it will set up the concurrent processes, run it locally, and it'll get through the simulations faster that way because it's running parallel processes. So let me just call this vehicles. We're doing init, we're doing parameter, and we're doing it distributedly, or in parallel, I should say. So let me save that out. And I will hit run. Oh, one thing, I could do the same thing that I did before if we want to return that table. We could return a results structure or results class, run result, and I could get it by doing vehicle runs dot get, that's it, result as vectable. So we'll do the same thing we did last time, get the results, and then use that to get our results and put them into a table. Let me see. Could copy it from prior run. Is it in this one? Yes. Is it here? Yeah, I could get these values. I will copy that into this file. So we'll just format the results before I run it. So we'll do the same thing that we did last time, but I'll do vehicle row labels, the process labels. This time we'll have a set of initialization labels. And then I'm getting the vehicle mass, engine power, and fuel economy. So those are the parameters we're changing. So I'll just have the output parameters, so those should match. I'll just let's put this on a few different lines. So make this each a different line. And we got engine power. And we'll do fuel economy. I think it's variable names. Then we do results as table.properties.units. So we got the vehicle name, the process name, initialization file, then we got kg for the mass, then we got W for the watts for the power, and then we got MPG for the fuel consumption. And then we have vehicle name, processes, engine file, vehicle mass, engine power, and then fuel economy. And let's just display the table. Table. And finally, we could do a rate table. And results as a table, and we could do full file. Doesn't work in directory. Results.x. 2, we'll call those results 2. And we'll use file type in spreadsheet. Actually, we could just call this maybe demo 3 or something. Call this demo 3. Okay, so we will run this and then see what we get. So it should launch additional processes as it runs. So I'll hit run and parameter new value. Oh, parameter value, right? That's here. Try it again. And there it goes. You can see it's launching additional processes. So we'll let it run and then come back and look at the results. Okay, now that those simulations finished, we can look at the results. And think let's look at the results here. Results as table. Oh, in this case, it's results. So results were returned. And let's just evaluate we obtain each of the results here. So then we could generate a table from those results. So I get a MATLAB table with the results in them. And I could set the out variable units. Okay, so I set the variable units. So that should be good. And then we could write out the table. So we display the table and then we write out the table. It was missing a parenthesis here, or I had a parenthesis in the wrong place. I should just be using it to create the full file present working directory with the name of the file. So we just evaluate this. And we should get another file, demo3. Now it looks like we didn't get some results for one of the files. So it looks like this file sometimes had an issue. We don't save that. If you actually wanted to go through, you can go through the results here. If you go to the original class and you iterate through the results, you can go through the result and check each one. If you do a get report on the value, so this is the actual MATLAB exception, so you could do a get report and then dot value, and you can see what the issue is. So there was an issue. It looks like there was an issue in the scaling file. I think maybe it was based on the values we were passing in. So let me just double check those for a second. Okay, so looking at the code, I guess what happened here was when I was setting this up, my values in the parameter list don't begin on the first column. They begin on the second column. So instead of making the value index go from parameter list, first row, first column, it should start with the second column. So what I was feeding in, if I say run this and debug it, you'll see that parameter name is fine. But then when I'm getting the parameter value, that's the string. So I was setting the engine power to this string. So I should have put this index as 2. So when I'm actually accessing the values, I want to start in column 2. So if I ran this and then went through this, you'll see that it's 8,500. So this is what I wanted to set it to. So what that ended up meaning was the simulations were okay, except I had an extra column that was added. And that extra column was setting the power equal to a string. So it wasn't actually running properly. So that's why all of these simulation results are redundant but done with incorrect values. So you really don't need this. So I could remove these and save that. So with that index starting at 2, I want to start on the columns that actually have values. So if I do that, then it will end up looking like this. One other thing to note, it's done with the string just because internally we're starting with an A vehicle file, and the A vehicle file is an XML file that has everything written as a string, and it's loaded into memory as a string. So when a parameter is overwritten in the vehicle or saved to a vehicle file, so I could save the vehicle mass to the vehicle file, that vehicle mass will be saved as a string. So when it gets loaded into memory in MATLAB, it will be a string. So a lot of the internal operations then are assuming things are a string. So the other thing that kind of happens is it might be slightly faster to convert it from a number to a string, because internally, if you pass it in as a number just before evaluating it, it has to turn it back into a string anyway, because the files themselves are evaluated as a string. So it's really doing a string replace in the file and not a numeric replace. It's one of the reasons why it's probably better at this point to convert it to a string, but it's not necessary. If you put it in there, the internal conversion will happen anyway. But it's just something to keep in mind, that because this class is designed to deal with the XML at the point you're overwriting things, it's probably better to just do the conversion and handle it as a string, because that string is going to be used later to overwrite the parameter in the file anyway as a string, and then that whole file is evaluated as a string. It's to allow for parameter overwrites even inside of an M file. In case the mass is used somewhere in the file, anywhere the mass is used, that mass gets string replaced as the value that you're passing in here. So that completes this demo.